Shake Table Lab by Hope Galusha and Carly Davison. Before Carly and I were given our straws, we designed a building sketch to plan the shape of our tower. I planned on having each story be 18 centimeters tall and 18 centimeters wide, so the overall height would be 36 centimeters. We also inserted X's on each wall for more strength, so it would be harder to make the tower collapse. Carly and I started by building the base of our tower and working our way up. The base is made up of 4 straws arranged to form a square and taped at the corners. The uprights were built next to support the first and second stories. For the second step of our building process, we added straws to the top to form a square and to separate the first and second stories. We measured to make sure the first story was the same height as the second story before taping the straws onto the structure. Once we had the first and second stories measured out, Carly and I inserted more straws for support. We placed 2 straws on the floor of the divider between stories and made triangles out of straws to support the walls. By the time our tower was complete, we had added several straws for support and designed a top for our structure. Construction paper covered the floor of both stories for more strength. We wove strips of paper on the roof as well to add a unique touch to our tower. The final construction sketch of our tower included the dimensions. We labeled the total height of the tower, the widths of the base and top, and the height of each individual story. The tower was 53 centimeters tall in total, with 2 18.5 centimeter stories and a 16 centimeter tall top. Once Carly and I had completed our tower, we did a static testing to find out whether our structure could hold weight. We placed 2 weights on each floor because we did not want to have our tower collapse from too much weight before the actual test. The structure seemed very sturdy, and Carly and I were impressed with how strong it was. Before our tower was complete, Carly and I noticed that the supports going straight up through the center of the tower were quite weak. With 2 extra straws, we doubled up so they would support more weight when we placed the sandbags on the floors of the structure. Carly and I discovered that the strongest parts of our tower were the joints between floors. Multiple cross supports came together at the same points, where we connected them with tape. These points in particular seemed very stable when we were static testing. One of the weakest parts on our structure was the first story floor. Without straws underneath the floor to support it, I worried that the second story would not hold weight. After discovering this, Carly and I crossed 2 straws in the shape of an X underneath the floor to add more strength. Throughout the process of building our tower, we used tape in many areas for more support. Tape was helpful when connecting 2 straws at a joint. On our uprights, we doubled up on straws and used tape to attach them as well. To complete our structure, Carly and I used construction paper as an extra supply. Using scissors, we cut squares of blue paper to tape over the first and second story floors. We used squares and strips of construction paper when decorating the top of our tower as well. Our first shake table video is of our tower supporting 8 sandbags. This is about halfway through the total amount of sandbags our tower was able to hold. At this point, the tower looks stable, and the cross supports have not yet begun to flex.
Who has the donut on top of theirs? I like that.
I think
Our second video of the testing shows when our tower finally collapsed at 20 sandbags. This meant that the tower was able to support 18 sandbags in total. The cross supports eventually gave in, and the tower broke at the bottom of the first floor. During the shake table testing, Mr. Clausette placed a sensor on our tower to track the motions the structure experienced. This sensor gave us the information shown on the graph. An XYZ graph is used to measure three motions: up and down, side to side, and the forward and backward motions of our building during an earthquake. The orange line is the y-axis, and it represents the side-to-side motions. The green line is the x-axis, and it represents the forward and backward motions. Finally, the blue axis is the z-axis, representing the up and down motions of the tower during the earthquake. Here I explain my thoughts on the Shake Table Lab and our tower. Hello, my name is Hope Galusha, and my partner Carly and I are going to share with you our thoughts on the Shake Table Lab. Carly and I's tower supported 18 sandbags in total and collapsed once we put 20 sandbags on the tower. Our building failed originally on the cross supports. They were not as well designed as the rest of our building. To strengthen our structure, I would have made X's for the cross supports instead of V's. This would have allowed the tower to hold more weight. Throughout the process of building our tower, I learned that you need to have a strong first story and cross supports. It is very difficult to build a safe, stable structure with limited resources. I enjoyed designing the tower very much. We were able to constantly come up with new ideas along the way as we experimented and use our imagination. Thank you. Carly reflects on her observations from the Shake Table Lab in this video.
Hi, my name is Carly Davison, and my partner Hope Galusha and I will be talking about our Shake Table Lab. Our building held 18 sandbags, and once we put 20 sandbags, it collapsed. Our building fell over because our uprights caved in towards the middle, resulting in our tower falling over. To fix this problem, I would have made X's for our cross supports instead of V's, which would have made our tower a lot stronger. I learned that the cross supports and the first story are very important to the strength of your tower. My favorite part of this lab was making the roof, which you had to be very creative and use your imagination. Thank you.